When sizing cable trays for high-voltage applications, it's crucial to adhere to the National Electrical Code, specifically Article 392, which covers cable trays, and related ampacity tables like 310.69 and others. First, let's address the minimum cable tray size. According to the provided information, the initial calculation suggests using the overall diameter of conductors laid side by side to determine the minimum tray width. A 750 kc mil unshielded copper 5 kV cable with a diameter of 1.62 inches is used as an example. If considering 18 such conductors laid side by side, the initial calculation suggests 18 multiplied by 1.62 inches, which equals 29.16 inches, leading to the consideration of a minimum 30-inch tray. However, the answer provided states that the minimum tray size should be determined based on the largest wire bundle that needs to be installed, specifically a bundle of 3 cables. The calculated width of such a bundle is 19.44 inches. It also states that according to 392.12, the tray must be sized by the diameter of the conductors laying side by side. The diameter of one conductor is 1.62 inches, and when multiplied by 3 conductors, it gives 4.86 inches. The answer concludes that a minimum 6-inch tray would be required according to 392.12. Therefore, the requirement of 392.12 must be carefully considered. The code requires the tray to be sized based on the conductor's diameter. Now let's move on to ampacity considerations. The ampacity of the cables depends heavily on the installation method. Firstly, for cables installed side by side with no spacing, which is installation method number 1, the ampacity should be reduced by 75% according to table 310.69 if they are uncovered. If the cables are covered for over 6 feet, the ampacity needs to be reduced by 70%. Secondly, for cables installed in a single row with one conductor space between them, known as installation method number 2, the ampacity can be used at 100% of the values listed in the relevant ampacity tables, such as table 310.69. Thirdly, when cables are bundled 3 in a bundle, labeled as A, B, and C, with the space between the bundles that is 2.15 times the conductor size, which is installation method number 3, the ampacity can be used at 100% of the values from table 310.67. Regarding the question of whether bundles can be placed side by side, the National Electrical Code does not explicitly address this scenario. However, the general recommendation is to avoid installing bundles side by side because this configuration can reduce the overall ampacity of the cables due to restricted heat dissipation. The NEC does permit multiple cables to be installed in the same tray, but it is crucial to space them adequately to facilitate proper heat dissipation. The specific spacing requirements depend on various factors, including the number of cables, their size, and the type of cable tray being used. To summarize, based on the information and NEC requirements, the minimum tray size should be 6 inches as determined by the conductor diameter according to section 392.12. The ampacity of the cables must be determined based on the specific installation method used, in compliance with section 392.13b. While the NEC allows multiple cables in a tray with proper spacing, installing bundles side by side is generally not recommended due to potential ampacity reduction. When working with high voltage cable installations, a thorough understanding of the NEC is crucial. Cable tray size and conductor ampacity are critical to safe operation.